Yeah. I think it's cold. All right, here we go. Fractions. So, we have to remind ourselves that we're going to add and subtract fractions. Okay? So, if I give you something like 1/4 minus 2/4, what do you get for an answer? What's 1/4 minus 2/4? Zoe? -1/4. And what did you do? What was the rule that you applied to solve that answer? You added the opposite because of that subtraction. What else? What'd you do? You're talking fractions. Why'd your denominator stay at 4? Why'd your numerator become a -1?
Because the greater number was negative.
Okay. So you basically did what to the numerators? What did you do to them?
Not pay attention to them.
Really? You didn't pay any attention to them.
Well, I did, because they were the same. I just did the full math.
So numerator is the top number. So what did you do to the numerators? Erin, what did she do to the numerators?
It says you got the denominator saved and you got circled the subtraction.
So she just subtracted them. So you did 1 minus 2 because why? Because these denominators were the same. So the rule that I'm trying to get out of you is if the denominators are the same, what do you do? Aaron?
Then multiply the numerators.
Not multiply. We're not doing multiplication. We had a subtraction problem. So if the denominators are the same,
You're allowed to add the subtraction.
add or subtract the numerators. Good. However, guess what? Only in 4th grade are you ever given denominators that are the same. After that, more often than not, what do you have to do? You have to find a common denominator. Okay, so with adding and subtracting, because they're the same. Remember, subtraction is really just adding the opposite, right? So when you're adding or subtracting, we're looking for the same denominator. Okay? But most of our problems are not going to have the same denominator. Most of our problems are going to have different denominators. Okay? And so we have to do something. We have to find a common denominator. So who remembers how to find a common denominator? What are you going to do, Vanessa?
You multiply them.
Multiply them by what?
Well, they both go to 12, so you times 3.
So what's that 12 called?
The common denominator.
A common denominator. What's another name for that 12? Malia. Least common multiple. And if you remember, we took our bubble method and we had to find the least common multiple, and we also found something else using this method. The greatest common factor. Greatest common factors are what we use when we're dividing something out and we're simplifying our fractions to lowest terms. Okay? Least common multiples are the same thing as a common denominator. So remember, you take your number that you're working with, your 3 and your 4, and you say, okay, this circle belongs to the 4, and this circle belongs to the 3. And then you take them to your primes. You need to stop talking. Yes? Okay. So, 3 as a prime is what? 3 times 1, which means that 4 as a prime is? 2 times 2. Okay? So if they had something in common, you would put the common piece in the common area of the Venn diagram, this section here. But they don't have anything in common. The 3 has a 3, so it goes in its circle. And the 4 has a 2 times a 2, so both the 2's go in its common circle. Okay? Or its circle. So now in order to find the greatest common factor, you're looking at the number that's in here. So do they have a greatest common factor? No. So really their greatest common factor is 1. Okay? And now the least common multiple says if you multiply all of these numbers across, you'll get their least common multiple. So 3 times 2 times 2, or 3 times 4 is 12. And so least common multiple and common denominator are the same thing. Okay? So now we know that our common denominator is 12. What do we do? How did I go from 1/3 to a 12? Vanessa.
Multiply 3 by 4, and you're supposed to do that to the top.
Okay.
4.
So I want to show you, because on the STAR test, they say, and you saw it on your standardized test question on your last formative assessment, okay? It said, what's the next step look like? And we do that next step in our head. We always write our 12 for our common denominator, and we do the step in our head. So I want to show it to you, because that's how it looks on the STAR test. So what am I really doing to the 1/3? I'm multiplying it by something to get it to become a 12. What am I multiplying it by? 4 over 4. And 4 over 4 is called what? What's another term for 4 over 4?
1.
A 1. It's an equivalent form of 1. And then I'm subtracting my 2/4, but I have to really multiply it by something to make it a 12. What am I multiplying it by? Julian, what am I multiplying it by?
3.
Not just 3. I have to multiply it by equivalent forms of 1. So what's the fraction that I'm multiplying? 3 over 3. Good. And this becomes 3 times 4 is this 12. And 1 times 4 is 4. And 2 times 3 is 6. And the 4 times 3 makes this 12. So now 4 minus 6 is 2. And my 12 stays. But what's wrong with it? Oh, it has to be negative. What else is wrong with it? Megan. It has to be simplified. Lots of you like to just leave your answers. Okay, you can't. You'll get them wrong. They are not correct. I gave you partial credit this week if you didn't simplify, but next week it'll just be 100% wrong. Every fraction you do gets simplified. Every single one. Okay? So when we simplify, we're really using our greatest common factors. So between 2 and 12, what's the greatest common factor? If I had to do another little bubble, what's the number that goes in here that they have in common? What do you think, Sabrina?
2.
It's a 2. So in terms of math, what you're really doing is dividing by 2 over 2. You're dividing by an equivalent form of 1. Because if we divide something by 1, it stays the same. Okay? So 2 divided by 2 is 1, and 12 divided by 2 is 6, and this becomes a negative. And this is my final answer. Okay, so I want to tell you all that I'm looking at your notes today, and I'm giving you a grade on your notes. So those of you that are drawing and not copying every single step down, or just spacing out and not copying every step down, you're getting graded today. Okay, so this is simplified. Everything has to be simplified. Always, 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 always. Now, we did adding and subtracting. We found a common denominator. We have to talk about multiplication and division. Okay, so if I have an example like 1/4 times 3/8, do I have to have a common denominator for multiplication? Sabrina, do I have to have a common denominator for multiplication? No, I don't. Okay, so what do I do? Aaron.
You do the numerator, you do 1 times 3.
Okay, so we're going to multiply straight across. And we get 1 times 3 is 3. And then what do I do to my denominator, Albany?
Multiply them.
Multiply straight across. 4 times 8 is?
32.
32. Do they have anything in common?
No.
You should be able to tell way back here. Do they have anything in common? No. Is there a 3 hidden in one of those numbers? No. Then they have nothing in common, and this is your simplified fraction. Okay? Now, if I had it reversed, 4 over 1 times 3 over 8, and this is my problem. Okay, I can do the same thing. I can multiply straight across, and 4 times 3 is 12, and 1 times 8 is 8. What's their common number? What's the thing? Because I have to simplify it. Connor. They both have a 4. So I'm really saying divide by 4 over 4, which leaves me with 3 halves. Okay? 3 over 2. Okay? Do I want 1 and 1/2? No, I don't. Because when I solve for x, I can't throw a 1 and 1/2 back into my problem. I can throw a 3 halves back in. So this is, I want improper fractions. Okay? And I'll show you why in a minute. Okay? But this is silly. To go from here to here is a silly step. It's extra work. What you should have done is you should have said, hey, this 8 is really 4 times 2. And now I have an equivalent form of 1, and I can cross it out. And I'm left with 1 times 3 is 3, and 1 times 2 is 2. Okay, and I'm looking for you to find your primes and to find your equivalent forms of 1 in this step, okay, up here, rather than doing this step, okay, because this is extra work and it means that you can make silly mistakes when you're dividing. Okay, now let's look at division. Division would be something like 2/5 divided by 1/4. Aaron. Well, first I have it looking like a fraction.
Yeah.
So what's my first thing that I have to do?
So first you have to put them into a multiplication by their sides.
Okay. So I want to rewrite it so that it has a division sign. So this reads as 2/5 divided by 1/4. And so I'm going to write it that way. 2/5 divided by 1/4. And who remembers the rule for dividing fractions? Maddie, do you remember? Do we divide fractions?
No.
No, what do we do?
Multiply by 2. Switch
We multiply by
the
the reciprocal. So 2/5 stays the same. The division becomes multiplication, and 1/4 becomes 4 over 1. Okay, do I have any primes that I can take out? Do I have any equivalent forms of 1? Yes? No? No. 2 times 4 is 8. 5 times 1 is 5. And this is simplified because I already checked for my equivalent forms of 1. Do I want this as a mixed number? No, I don't. And here's why. I'm going to show you. So if I have 2/5, actually, let me get a new paper so I have more space. If I have 2/5 x equals 12/15, how do I get x alone? Zoe? I don't subtract. There's no addition in that problem, therefore I'm not going to use subtraction. I'm going to divide by 2/5 because this said 2/5 times x. And what's the opposite of multiplication? Division. So I'm going to divide because 2/5 divided by 2/5 leaves me with a 1. So I'm left with my x. But if I do it to one side, what do I have to do? I have to do it to the other side. So this means 12/15 is divided by 2/5. So what do I write here to make it something that I can work with? Michael, what do you think I should write?
I think you should write 12/15 divided by...
Do you want a big line, like a fraction bar?
No.
You want it divided by 2/5.
Yes.
Okay? And now what? Keep
Then
going,
you
Michael.
have to multiply... No, then you have to make
Okay?
And then you multiply.
Notice I changed my sign from division to multiplication, and then I used the reciprocal. Okay? See any equivalent forms of 1?
Yes.
Okay, what?
2 and 12.
So there's a 2 and 12, right? 12 is really 2 times 6, so I can cancel out my 2's. It's an equivalent form of 1. What else?
5 and 15.
In the 5, the 15 has a 5 times a 3. So my 5's are gone. So I'm left with 6 times,
6 times 0.
not 0,
1.
1. It's a 1. 6 times 1 is 6. And 3 times 1 is 3. What did we miss? That the 6 is really a 2 and a 3. The 6 is really a 2 times a 3, and these 3's can go out. So you're really left with 2. And 6 divided by 3 is 2. Okay, so I get x equals 2. Okay, does that make sense? Okay. Now, what do we always have to do? We always have to check it. Okay? And when we're checking, we're starting with our original problem. 2/5 x equals 12/15. Okay? And then we're plugging in the value that we solved for, the 2. And we're saying 2/5 times 2 equals 12/15. Can I multiply a whole number times a fraction? Connor, can I multiply a whole number times a fraction? Okay, so how do I change a 2 into a fraction? 2 over 1. Okay, is there any equivalent forms of 1 that I can take out? So it's reduced? No. So 2 times 2 is 4. And 5 times 1 is 5 equals 12/15. Huh. Kind of doesn't look like it's true. What do you think, Zoe?
Times 3 over 3.
I just get to times by 3 over 3? What is 3 over 3?
1.
It's a 1. So can I multiply anything by 1?
Yeah.
Yeah, I can. So really, what's wrong with this? It's that this is not, it's not reduced. So in its lowest terms, I really have 4/5. Right? So 4/5 equals 4/5. So this actually is a true statement. Okay? What's another way to check it? To make sure your fractions, how's another way to check it besides reducing to lowest terms? Malia? Okay, I'm still reducing it, right? 6/3? Where'd you get 6/3 from? Where did you get 6?
Right there.
Oh, here. You could have plugged that in. Okay.
And that's 12.
That is 12/15. What else? What else can you do to compare fractions? I'm looking at comparing this 4/5 and this 12/15. Aaron.
You can see that since you see 4 can go into 12, and since it can, it goes into it 3 times, and you see that 5 can go into 15.
Okay, there's another way to compare fractions. You can cross multiply. So 5 times 12 gives me what? What's 5 times 12? 60. And 15, whoa. 15 times 4 is 60. Does 60 equal 60? Yes. So you can use cross products is what we call this. You multiply in an upward angle, upward diagonals, and they can prove that your fractions are equal. Okay, there's one other way to prove your fractions are equal. So we can reduce them to find out if they're in simplest form. Okay, we can use cross products, and there's one other way. What are fractions? Someone tell me what fractions really means. What do you think, Aaron? They're division problems. So if I divide 4 divided by 5, what do I get?
4 divided by 5.
Come on. He's not the only one that knows how to do division. What do you get if you divide 4 by 5? You don't get 1. You have 4 divided by 5. 5 goes into 4 0 times.
0.8.
You get 8, 0.8. So 4/5 is really 0.8. What's 12/15? 0.8. If you were to do the division, it would come out as 0.8. Okay? So another way to compare fractions is by taking them to their decimal form and doing the long divisions. Okay?